Morning, sir. My name is Nikita. I am from EC branch. My subject is computer architecture, and my topic is a survey of computer architecture, simulation techniques, and tools. Coming to introduction, computer architect use simulation to access different design options, test new research idea, and analyze the performance and power consumptions of different processor models. Analytical models are not suitable for evaluating architectural and microarchitectural designs and design variations as they produce inaccurate result because of the huge amount of configuration and small details that can cause small variation in performance, which can consume many power to evaluate the different architectural variations, and they produce some simulations. Simulation is considered to be the standard performance modeling method. The majority of published research is based on the use of simulators to analyze the performance of new ideas. Many computer architecture simulations supports various instruction sets architectures, microarchitectures, and are based on different simulation models ranging from trace based to cycle accurate, which analytic models not only evaluate architectural designs but also design various variations to which they produce inaccurate result. Coming to abstract, computer architecture simulation is an essential aspect of modern computing research and development. It enables architects to evaluate different design choices, predict system behavior, and optimize performance without the need for physical implementation. This survey explores various simulation techniques and tools employed in the field of computer architecture. We categorize these techniques based on their granularity, modeling approaches, simulation objectives, and target architectures. It enables some design choices, predict behavior without any physical implementation. We categorize these techniques based on their granularity, modeling approaches, simulation objectives, and target architecture. Further, Furthermore, we discuss the strengths, weakness, and typical usage scenario of each technique, providing insight into their applicability and effectiveness. Coming to methodology, simulators can be classified into various groups based on the details of simulations, scope of target, and input of the simulator. Simple Scalar is a speed optimized version of SimSafe. SimCore is a fundamental simulator and is a visual functional simulator for MIPs. HASC is a tool for high level simulation and visualization of computer architecture and is a GPGPU simulator. Functional simulators. Functional simulators are faster than emulators but cannot keep track of microarchitectural parameters. Simple Scalar Simulators is a comprehensive toolset with various simulation models such as a SimFace, SimSig, SimCore, etc. are a dynamic binary instrument tools are used to instrument a binary programs. And here is a block diagram which consists of a high current indicator, driver, accelerator, pedal plus gear, power output converter, vehicle is subdivided into current, speed, acceleration, temperature, and road orientation, traffic condition, over temperature indicator, where the high current indicator is connected to driver and road orientation, traffic condition, over temperature indicator is directly connected to the driver, and the driver of an output is connected to accelerator, and the output of an accelerator is connected into power output converter, and the power output converter is directly converted into vehicle, and the vehicle is subdivided into current, speed, acceleration, temperature. Time simulator. Timing simulator simulate the microarchitecture of processors, producing detailed statistics such as instructions per cycle, that is IPC, program runtime, performance of a memory system, and other details. They have different subtypes depending on the degree of details included, which produces some statistics such as IPC, which is instruction per cycle, and it has different data types, which depending on the degree which it includes. Cycle level simulator. Cycle level simulator includes some architecture by imitating the operation of the simulated processor for each cycle. They are slow and utilize a considerable amount of memory compared to the functional and other timing performances or simulators, which has some cycles, and each cycle consists of some simulated processes, and they utilize some architecture simulations which they produce cycle server simulators. SimFast is a fastest functional simulator for simple scalar, while SimOut orders is a detailed micro-architectural timing model that supports speculation. Event-driven simulators. Event-driven timing or performance simulators using queues to jump to the time when an event is scheduled, such as SCSC, SCSC, RSIM, Smart Flexer, and SlimFlex. SlimFlex can be performed fast simulation of uniprocessor and multiprocessor system, but implements a simple in-order CPU model. Interval simulators are new simulator techniques that balance simulation accuracy and speed. They use a regular instruction flow to break down into set of intervals based on misevents. Special purpose portions of architectural simulators like branch prediction and memory system can be used to simulate the misevent and find their exact timing. An analytical model is used to estimate the duration for every instruction. Here is a modeling and analysis. Modeling it consists of a memory hierarchy simulation and branch predictor simulator, which is integrated with processor cores, and functional simulator is also directly connected to processor cores. And processor core is subdivided into old window and new window. Full system simulator. A full system simulator simulates all needed input-output devices, memory and network connections needed to boot and run any OS, allowing applications to execute their system calls directly on the target system. Trace-driven models do not include runtime changes in behavior of multi-threaded applications, making them unsuitable for parallel and timing-dependent systems. Shade is a trace-driven instruction set simulator. Shade is also used to generate trace, and simple scalar has the capability to run simulations for trace files. Cheetah and MASC are other trace-driven simulators that simulate different cache configuration. Few research works have been put forward to efficiently use trace-driven simulators for multiple threaded workloads. Execution-driven simulator. Execution-driven simulators do not use trace files and instead use binaries or executables of benchmarks for simulated target missions. Simple scalar RSIM, SCSC, and ESCSC are examples of these type of simulators. Direct or native execution is a technique used to simulate particular portions of codes and execute the rest of the applications directly on the host machine. PTL Sim, Tang, and FAST use these approach to speed up simulations. Result and discussion. The result and discussions may be combined into a common session or untamed separability. These may also be broken into subsets with short, revealing captions. Trace-driven simulators. Trace files are used as input to trace-driven simulators. Pre-recorded streams of instruction exceeded by benchmarks with fixed inputs. However, the size of trace files can be limit the total instruction count and or the number of trace files used at once, leading to slower simulation time. Different trace samples are and trace reduction techniques are used to resolve these problems, but these simulations usually do not model execution of misspeculated code, which can affect simulation time. Conclusion: it concludes simpler produces the minimum absolute error, and the ZSIM is the fastest for single core simulation. It also highlights the importance of validating simulators and points out some sources of inaccuracy in computer architecture simulations. Additionally, there is a need for new methods to validate simulators for multi-core processor simulation, as multi-core simulation inaccurate for simulators that were validated for single-core process show high error rates for multi-core extensions. Finally, simulation validation is important to ensure confidence in the procedure, result, and facilitate responsibility. Thank you.